Welcome to our backyard. This is the Backyard Philosophy Podcast. We are two friends having a discussion after everyone else has passed out or gone to bed. Grab a drink and listen as we discuss everything from automation, space exploration, and why the meaning of life is 42. Walking down the aisle of the supermarket, I grab some table salt, look at the label, GMO free. Now at this point, I'm more concerned about what genetics that table salt has that I was not aware of, because as far as I knew, salt was not alive. But apparently not only is it alive, but it's reproducing somehow, and it has varying different genetics between the salt particles. That's not actually the case, but today we're going to talk about why there's anti-GMO stickers on everything, what GMO means, kind of some misconceptions. Is it good, bad? What does it mean for us as a society? Will it feed us? Will it kill us? But before we get into that, Mike, how are you doing? What are you drinking?
I'm doing fantastic, my friend. And I'm drinking a drink that I like to call the sin. It's gin, vodka, cranberry juice, and lemon juice mixed together. What about you? What are you drinking and how are you doing?
Nothing that fancy, just a Coors Light. So I want to start it off talking about the difference between genetic modification and selective breeding. Selective breeding is a process that's been going on for, honestly, who knows how long. I mean, I really don't know, but a long time. Anytime. I mean, one of the first recorded example would probably be like Mendeley's peas of breeding for specific traits. But I'm sure long before that, farmers would breed some of their better crops with some of their better crops to get better yields. And I know just from being in Illinois, farmers down there, not too long, like one generation, two generations behind us, so your greatest generation, they were saving their seeds from their higher producing plants and breeding them with their other highest producing plants. And that's why yields have been increasing for so long, because we're just finding those better plants and breeding them. So you're breeding for a selective trait, yield in that sense, which differs from genetic modification, which is where we take a trait from a different species and put it into a target plant. So just give a quick example of we're going back to trees. The American chestnut tree was completely wiped out. Well, not completely. There's a few trees left on an island. And it used to be all over the eastern United States. And they were able to take a gene from rust that is a gene that defeats a fungus that attacks the wheat plant, or takes a gene from the wheat plant that codes for rust resistance. We're able to put that into these American chestnuts, which have been extinct from the ground for a long time, and now it's like 99.9999999% American chestnut and a very small percentage of wheat plant. So it's an entirely different gene taken from a different organism and put into your target organism. It's not the same as breeding chestnut trees that are resistant to the blight, which is what was ailing them, a European chestnut blight, that are resistant to that, and breed them together, because that is much slower.
Well, before we get too far into modifying plants by human means, I think it's important to note that mutations happen naturally in nature. And Nick, since you deal with the trees and the plants a little bit more,
yeah. So
could you tell us a little bit more about mutations?
Everyone knows this. The major way we get mutations in our genetics is through reproduction. When you take some of your mom's genes, cross them with some of your dad's genes, and you get your genes. And everyone knows you have a unique genome. Even identical twins have different genes, and different species will choose a mate based on something that they see that will give their offspring a better chance for survival, which is in a sense selective breeding, similar to the corn growers breeding their two best growing plants with each other to produce a better grown plant. But you can also get genes in other ways. So one of the biggest is radiation. Ultraviolet radiation can cause genes to mutate, and this is most commonly shown, I guess, is when you get a cancer, like a skin cancer from sun damage. And then you also can have mutations that happen from, so your genes, when you're creating a new cell, will copy itself, but maybe it didn't copy correctly or it misprinted, and so you just have a random mutation. Now, your genes like that, your random mutations from radiation or not copying correctly, not reproducing correctly, probably will not transfer down to your offspring. Usually, that's not how that works, but it's still a change in the genetics. And there's a few different other ways, but the point is, this is something that can occur naturally. I mean, viruses can come in and change your DNA as well, hijack some of it, insert their own code, genetic code for what they want. But there's changes to your genome is not something that's brand new. This can happen through time, and it will happen as just normal breeding cycles will change the genetics of everything.
To add on to that, I want everyone to think Darwin. We've all heard about Galapagos Island, birds changing. It's the same thing for plants. They mutate to the best environment, whether the environment has changed, whether, new food's available. It's the same thing with every plant. And that went on for millions upon millions of years until humans came around. And bringing back to what Nick was talking about, when the first ancestors of ours were starting agriculture, choosing the best plants, which I believe most people, by most people I mean most scientists, agree happens the first agriculture somewhere in the Mesopotamia area. For some reason, that tends to be the Goldilocks zone for the human species to start things. And what they hypothesize is it was a semi-nomadic tribe that would make rotations. So they would follow a path, whether it was following, herds or something like that, but they would always leave back. But they would leave the plant seeds from food they liked the most tasteful in that location they were camping or staying. So they were semi-nomads. This would eventually turn into full agriculture. And, well, if you have something you like, you kind of want more of it. So when you want that wheat plant that, makes bigger, tasty bread, because let's be honest, we all love bread. Throw some butter on that, delicious. And now that we're developing more into an agricultural-based society, well, if we can produce more bread with this one plant and taste better, well, forget the little wimpy one. Let's stick with the hefty. So we keep planting those, keep growing those, and keep crossbreeding those, and we're modifying the plant's genes by breeding them. We're breeding them just like we would breed sheep, cow, any other livestock. Same thing with plants. That keeps going on for thousands, if not tens of thousands of years, until about 1866. In the late 1800s, where science was becoming much more prevalent, where it was less cuckoo and more, what does the math say? A Gregor Mendel, an Austrian monk, funny enough about monk with genetic modification, I feel like that's an oxymoron, but the Austrian monk bred two different types of peas and identified the first process of genetics. This is where we have the first idea of genetics, is in 1866. So for tens of thousands of years, humans have been crossbreeding plants, but not understanding why that is. And it wasn't until 1866 where we got the details of it. Fast forward a little bit, 1922, the first hybrid corn is produced. And here's the kicker. It's also sold commercially. 1922, right before the Great Depression, when everything's booming, food became more easier to grow and more producible. And with no FDA yet, which we'll get to in a minute, it pushed straight to the market. Then the 1940s roll around. And, well, during World War II, it was do everything we can to win, no holds barred, must move forward. And that was the same for producing food. Plant breeders learned to use radiation and chemicals, randomly change an organism's DNA. Like Nick was mentioning earlier with ultraviolet, The ultraviolet changes the RNA being produced, your DNA being produced. Granted, it's kind of different when it's off to your offspring, but if you're able to change the DNA, not the RNA, you're able to keep going forward. And since we're in the atomic age, having control of the atom, we are able to make more leaps and bounds using radiation. Then, as World War II ended, we proceeded on with science, and thanks to Project Paperclip, brought over more scientists who were part of the Nazi regime, which helped us produce new types of food and stuff like that. The 1970s rolled along, more specifically the 1973 year, where a biochemist, Herbert Boyer, sorry if I messed that name up, and a Stanley Cohen developed a genetic engineering method by inserting DNA from one bacteria into another. This is like the predecessor to CRISPR, pretty much, is the 1970s. So now, less than 100 years ago, we just in 1866, we figured out what genetics were. We've always been messing with plants since humans started farming, but it wasn't until 1866 that we figured out what it is. And less than 100 years later, we figured out how to add bacteria into it. Talk about human growth and amazement of what humans can do. Then, 1986, the FDA rolls around. When the FDA rolls around, and we've been modifying plants, government's going to get some way involved with farmers. And Nick, I think you know a little bit more about the FDA than I do because, well, I'm not in that world. So how does the FDA get involved with genetic modification of organisms?
Their role, I guess, the FDA's goal is to ensure that food is safe for the public to eat. The FDA sets and enforces food safety standards. So, all those little markings that probably mean nothing to most people on food, your sell-by dates, best-by dates, they're the people who run all those tests that say, okay, you leave this food out at this temperature, how long will it stay good? How long is it safe for consumption? And then a reasonable safety mark is set in. So they're, in charge of making sure everything is safe for us to eat. So specifically, when they come to doing in GMOs, what they're kind of trying to see is, do those GMOs meet the same standard for all other foods? So, and what that means is, so say you're growing, here's a real world example for you. Strawberries can be grown in places that are a little bit warmer, but people would like to grow in places that are colder. So they take a gene from a fish in Alaska that swims in colder water. It has like almost antifreeze in its system to keep it from freezing. They put that into the strawberries to prevent them from getting frost damage, which, like we'd hit on in the podcast about organics, frost damage and cherries is not good, and it causes loss of crop, reduced yield. And what that does, though, is now people who are allergic to fish may be allergic to that strawberry. So the FDA figures out, okay, this food, who is allergic to it? Like if you're not supposed to eat fish, as a person, you would think you're completely fine to eat strawberries, right? But if the strawberry has some fish genetics in it, then it may not be completely safe for you to eat. So they have to figure out, is this product safe for people to eat?
And for those wondering, humans have been not just modifying, crossbreeding plants just to taste better, get more food, more quantity. It's also just for survival, like Nick was just mentioning with the frost. Mother Nature's a cruel mistress. So be able to survive, droughts, storms, diseases, bugs, which we will talk to you in a bit. It's kind of the main goal of genetic modifications. And fun fact, Nick, do you know what the first fruit was to be genetically modified, which just happens to be the first organism to be genetically modified for consumption is?
Was it apples?
No, it was tomatoes. Apples, surprisingly, did not become available to the market that were genetically modified until 2017. But
Yep.
tomatoes started off
I
in
feel like I knew that
1994.
after my research. I just wasn't. The way you phrased it, you set me up for something else. Anyway,
Well, before I move on to tomatoes and let you continue, I just want to throw a fun fact. I thought it was quite interesting. Tomatoes have a very simple DNA. It's not the right word choice, simple, but it's what I can choose from because it's very similar to the cayenne, some sort of pepper family. So it's easy to change tomatoes into spicy tomatoes, which taste like peppers almost. Like they have a very simple manipulative DNA, which is kind of fitting that the first one we modify is kind of the easiest. It makes sense, but it's kind of nice that we start off with
no,
the
you're good.
basis. Sorry, Nick, didn't mean to
So
interrupt you
the
there.
FDA has a few different programs, and it's similar to most of their other programs that pretty much every new food product needs to go through some kind of FDA inspection. They call for GMOs, it's called a biotechnology consultation, but it's very similar to, in fact, the way pesticides get regulated. So, they look at, does food from a new plant contain a new toxin or allergen? Is food from the plant nutritionally different from its traditionally bred counterpart? And they also look at, say, does this food present nutritional value? Because if it's not, going to feed people the same way, it's probably not worth growing. But there's also a few other agencies who look at GMOs before they come on the market. So the EPA, like we talked about in the pesticides podcast, which these all kind of tie in together, so might give it a listen. EPA, the Environmental Protection Agency, which is responsible for regulating pesticides, if the GMO has something inside of it that prevents pests or resistance to insects or resistance to a fungus or a bacteria, that's technically considered a pesticide. It's called a plant incorporated protectant, and so then that has to go through normal like pesticide regulations through the EPA, do all that testing, and then the U.S. Department of Agriculture oversees. Basically, they say, okay, will this crop, breed? Will this plant breed with other plants? Will it become a problem for other neighbors practicing a different form of agriculture? So it goes through three different federal agencies before it's cleared to eat.
Yeah, that sounds like the government for you, but I'm okay with that. If when we're messing with Mother Nature, I kind of like being slow and patient because Mother Nature kind of moves slow and patient, so we should follow by her example. Nick, out of curiosity, I'm sorry, I'm just full of facts. I kind of went down the rabbit hole of researching genetic modifications. Do you know what the most common
The
fruit
most
slash vegetable
common,
is that's genetically
there's not
modified?
that many, so I'm going to have to say either corn or soybeans.
We're Midwestern, it's soybeans. They account for almost half of all the GMO crops grown, which is absolutely amazing. Out of curiosity, Nick, I don't expect you to know this, but I'm just throwing it out there. Is there an FDA for the world? Because most GMOs are third world based, and I don't know the regulation for taking food to a third world country, let alone genetically modified food to the third world country.
So I
Like,
think the
is
the
it? Does it? I
WHO is
assume.
partly responsible for that.
Well, those
But
countries are screwed
I
then.
know right now, I know, yeah, like you said, a lot of third world countries are working on genetic modification, but I don't know under what agencies. I assume it's their own agencies. I know, like, right now, Burkina Faso, Cameroon, Ethiopia, Ghana, Kenya, Malawi, Mozambique, Nigeria, Rwanda, Tanzania, and Uganda are working on a lot of different genetically modified organisms, including insect-resistant cowpea and
Wait, run that
insect
back one more time.
resistance cowpea. I'm assuming it's just like a pea. Um, bananas that are
Is
fortified with
it
vitamin
like the?
A.
Hang on, we're not skipping over that. Hang on. Is it like the cow eats whatever
No,
food and the
it's
pea becomes like a natural
just a pea.
insecticide?
It's a legume. It's just called a cowpea.
Oh, I'm thinking P. I'm thinking P
Oh,
E
yep. I
E,
think I
not
figured out
P
where our
E
problem
A.
was.
Okay, I'm just dumb.
Yeah,
Sorry,
but they
everyone.
got
Please continue, Nick.
vitamin A fortified banana, a potato that's resistant to blight disease, drought tolerant corn, drought tolerant and insect tolerant corn, plants that are more water efficient, nitrogen efficient, and vitamin A fortified sorghum and sweet potatoes, and all sorts of stuff.
Well, two things. One, those are all countries I think doing their own programs. I am curious though if like when the United Nations brings in food, I assume they must. I think you're right. They probably go through the World Health Organization. But it's just I'm wondering what the logistics of transferring genetically modified food from country to country. That's got to be such a nightmare. But Nick, since you brought it
So
up
I'm just reading
with meat and
this article real quick. It says each country manages its own GMO seed production and distribution. They usually use local seed companies. Some crops are patented, so farmers will have to pay for these seeds, just as they pay for hybrid varieties. But others are developed by the public sector, will be royalty free and available to farmers for free. So that, and some can be saved so that they can be used year after year. And it says each nation
okay,
exercises
but
sovereign control over GMOs. So they decide which GMOs can be developed and released to farmers, and every country has its own regulatory agency overseeing GMOs and its own set of laws that govern their use.
I think it's a bold statement to think every country has its own regulations on GMOs. I don't see Somalia having GMOs over certain rice and grains that over time. But I could be wrong. I hope I am wrong. But Nick, since you brought it up with GMOs and fish/meat, I think it's important to note that GMOs just don't stop with fruits and vegetables. They get into your fish and beef as well. I mean, in 2015, the first GMO that was animal based, I think is the correct way to kind of say it, was approved. That was called a Aqua Advantage, and it was a salmon. It was to grow salmon faster and bigger, if I'm not mistaken, so we could eat salmon more, which is weird to me. I assume we'll talk about it later in the podcast, Nick, but first reaction, how do you feel
Um,
animal versus
yeah,
plant
it
genetically
feels weird
modification?
when it's an animal, doesn't it? Compared to
It
plants,
does. It
because
really
I think
does.
animals are so much more complex than plants.
Yeah, I can
I
see
mean, it's
that.
just like,
But
yeah.
before we get into ethics, I want to say that I just want to keep that floating in your mind so you can think about it a little bit. I want to stick with the third world country for a little bit because I think GMOs have the. All right, in case everyone figuring out, I'm kind of a fan of GMOs. If we're able to feed the growing population so let people starve to death, we use less pesticides, herbicides, whatever we need to be more naturally resistant, and we're able to create healthier foods for everyone. I'm not really seeing a downside. So, clear
And
the air.
just
I'm kind of a
kind
fan
of
of
to go,
GMOs.
I am as well, but there's also no animal products, no GMO animal products available for consumption in the United States as of this moment. So you can
That's
make,
good to
like, they
know. I
can
did
make
not know
them,
that
but
fact.
you can't currently produce them for consumption right now.
Interesting. I'm wondering what the hiccup is in that. But going back to third world countries, because I think that's a huge topic point. There are 7 billion people, and within a decade, it'll be 9 billion people. We need to feed everyone. And genetically modified food seems to be leading the path to people so people don't starve. I mean, 54% of all GMOs worldwide are grown in a third world country, and that's as of 2013. I imagine it's only increased. And one game changer that I came across, which I did not know such a simple thing could impact so many lives was a genetically modified rice called the golden rice. This is a GMO rice. It's yellow in nature, hence why it's called golden. And it's been modified to have vitamin A in it. I'm not sure if there's any other vitamins in it. Can't quite remember. But this golden rice, which has been introduced to many third world countries to help feed people, children especially, helps save and prevent 600,000 child deaths a year. A year, over 500,000 people. And that doesn't stop there. With that alone, just preventing deaths, it also helps prevent another 500,000 children from going blind. So in total, about 1.1 million children in third world countries are positively affected by GMOs. So they're not either dying from vitamin deficiency or they're not going blind. I don't know why there are so many people against GMOs if we can help 1.1 million kids have a future and a life.
Yeah,
That's
that
amazing to me.
completely incredible. Didn't that happen like the 70s or something? Like that happened a while ago, the invention of that rice. So it saved a lot of lives.
Yes, I believe it happened in the late 90s, if I remember correctly. So it's been going on for at least almost 2 decades. So 2 decades at 1.1. So nearly 21 million children have been positively affected by GMOs. That's mind-boggling. And especially when it's like third world countries where we want to help our fellow humanity, and if we're able to create food that are rust resistant, like we've done for some trees in America, bringing back the trees, Nick, just for you, or just so the plant has a natural insecticide so it doesn't get destroyed by locusts or some other beetle or something like that. So there's simply just a little bit more food. That little bit more food allows you not to focus on food, allows you to think about education, made you think about free time. We went from, like, our ancestors went from only focusing on food, and once we had abundance of food, have craftsmanships, have, you know, potters, painters. We're able to follow arts and different trades if we're know that we can sustain ourselves with food. And if we can do that for third world countries, that's millions of other artists, inventors, musicians, all being born and able to
Yeah,
create,
and
which is just
it's
amazing
not
to me.
just the rice with the vitamin A. Like we talked about, they're not reintroducing, they're introducing all sorts of vitamin fortified uh, products. It feels weird calling them products. Organisms, plants, vitamin fortified plants into all sorts of developing countries, and it's people are going to be able to eat, get more from eating less, right?
I mean, that's all right. So that's kind of a double edged sword. Completely agree with you. But like a main reason, well, not a main reason, a reason, because there's lots of reasons, Americans are fat because our wheat grain is much different than the rest of the world's. It's much more hefty, more bang for our buck, which creates more problems. But honestly, I'd rather have the problem of losing weight than starving to death. That's all. I'm gonna weigh my options, and I'm definitely gonna go with. I'd rather run more than be starving to death. So it does have some benefits, and it also has some cons.
Oh,
But
for
I think the
sure.
pros far outweigh the
And
cons.
I kind of want to throw in here just a list of plants that are okay for genetic modification in the United States. So, like I said, you'll walk around the grocery store and see GMO free labels on all sorts of stuff that has no business having a GMO label on it, like corn. But so you have alfalfa, you have canola, cotton, corn, soybeans, like we said, it's about 50%. Sugar beets, cotton, and what else we got?
So cotton's really interesting to me when researching this GMOs. I'm gonna let you finish your list
Yeah,
first,
we
but
can.
if we can, I would like to
Papaya,
talk about cotton.
potatoes. If there's one thing we like, it's potatoes.
The
Roses,
Irish in me is so happy right
squash,
now.
and tobacco. And there we used to have a tomato, like you said, but that was production was stopped of that tomato. And then we have apples that are approved for genetic modification, but they haven't been cultivated yet, along with chicory, flax, grasses, plums, and a few different potatoes that are still waiting. And if you go to the FDA's page, you can see what plants are waiting for consultation. And we have a corn that has a change in composition, and sugar that is waiting for, that's going to have be more resistant to insects. Cotton, Fuji apple, soybean, just some changes. A cotton with an herbicide tolerance, sugar cane that's insect resistant, rice that's insect resistant, canola, herbicide tolerance, soybean with altered growth properties, potato. There's a lot of potatoes that we're waiting on with change in composition that have lower levels of sugars and increased blight resistance. Pineapples.
So you're telling me I can eat more French fries without worrying about the sugars?
The future is now.
Oh my God, Nick, you're talking dirty to me now.
A pineapple and a potato that has reduced black spot bruising and again lower levels of sugars. Corn with insect resistance, corn with herbicide tolerance. Potato with reduced black spot bruising, lower levels of sugar and blight resistance. Corn with altered growth properties. Apples that don't oxidize as fast. And that's pretty much it. Another starch potato, soybeans, alfalfa, and so the what I think, like we talked about with Trent in the organic one, with the how the bruising, people throw out bruised apples. When we make apples and these guys are making potatoes tougher, you're going to have less food waste.
That's always a benefit. Less food waste is, I don't know about a win. I can't see how that's a downside.
And so this is we're right on the edge. So I want to bust this myth before we get on to cotton. So there's a myth out there that genetic modified organisms do not improve yields. Well, that's technically true. So you're not, if you are growing a corn that's resistant to insects, your yield is not going to be improved by using a genetic modified organism. It overall, over the course of all the corn producers, it will improve yields because you're not having corn fall to that insect. So if you are harvesting 120 bushels an acre, you're only going to, next year, you might still harvest around 120 bushels an acre, but you won't lose that corn to insects. So you'll see a lot of anti-GMO movement throughout the fact that GMO doesn't really produce increased yields, which is 100% true, but that's not the objective. The objective is to not lose your crop to something that's trying to kill it in that instance. Now, I'm assuming which I don't think there's any on the market right now, the ones that are going to increase growth properties, I'm assuming those will increase yields, but they're not on the market yet.
Nick, you have inspired so many more questions than I was originally going to ask now. So this is going to be a very interesting episode. But before I get to those, I want to talk about cotton. Cotton's very interesting to me because they're genetically modifying it not only to need less water, so, less waste, not only to be insect resistant, but there are rumors now to make cotton softer by genetically modifying it, which is very interesting to me, where it's almost like it's not like this, but is the best analogy in my mind, where we're taking synthetic material and growing them through organic material. Imagine growing a cotton plantation that is less water dependent. You need less less pesticides, and the material that comes out the end of it is softer than normal cotton. Feels like a very interesting future. And since you brought it up, Nick, I just want to throw this out there. This is kind of a late study. I was having a hard time finding studies close to this current time of recording, but as of 2016, only 37% of the general public in America think GMOs are safe. That is, I have no idea why the number is so low. And so I'm going to pass this on to you, Nick. How do you feel about the cotton being, I don't know why that's so fascinating to me, cotton be able to be softer than cotton, and such a small portion, I mean, a third of the population of the United States, so 100 million people of the 350, 60 million people in the United States think GMOs are safe. Granted, it's a late study, but let's just assume the numbers are the same.
So I think I'm kind of talking out of my ass here because I am so far removed from cotton. I have no idea how they decide what varieties, or if they have varieties, families, however they do that, to grow. But I'm just thinking that most cotton is probably grown for how it survives, right? They'll, as a secondary trait, you'll select cotton for how it feels, but you're selecting the winners, the ones that don't die.
I would say not necessarily if it lives or dies, but I would say yield. I would
Or
say
yield, yeah.
yield is
Yep. That's a good point.
that's what I would think.
Yeah, exactly. But it's all the same, kind of the same. You want the one that, you're going to get the most money for. So you're not necessarily selecting on softness. Now, I have no idea if they grade cotton. Like if you grow a softer cotton, you get paid a higher percentage. Maybe the case, maybe not. I have no idea. But I'm assuming that wasn't really, you're probably just trying to get your crop to survive. Like, we can grow trees that are straight, like the trees everyone wants. They want those older trees that are stronger, tougher, but you're not willing to pay for it. People want to pay for the trees that's cheapest. So that's why we grow trees that grow fast and grow strong enough to still support everything and strong enough to survive drought, all the stress, but we're not necessarily selecting for the characteristic that people want because there's no way when we send a tree to the mill, it doesn't get tested for how strong it is. There's no measuring system. Now, I don't know if there is for cotton. If there is, it probably doesn't apply.
Well, not for toughness, but there is. I just did a quick Google search. There is a U.S. cotton fiber chart for grades of cotton, which is color grade, leaf grade, how it's spotted. Cotton's a lot more in depth than I thought it was.
Is
So
texture on there?
not that I'm seeing. It tends to be it tends to be more color based. But again, I just want to point this out. The changing of softness has been talked about, not attempted yet. It's that's still something they want to talk about. It was what I saw when researching genetically modifications. Cotton came up of it's positively affected the cotton industry quite a bit, but they were talking about growing genetically modified cotton with different colors and different softness. And
Right. And so I guess the point I'm getting at is for so long, agriculture has been limited by growing what survives, right? Like growing the biggest yields, the toughest plants that can survive drought, whatever it is that they face, insects, whatever they're facing, that you want the plant that's going to survive that, not necessarily the one that, at the same time, you want a good, producing plant too. But you're not selecting for these secondary traits. So now that we have an advantage, it's not year for year fighting against Mother Nature. We're able to take a leap ahead and get set up. We can now select for secondary traits that would be nice to have, like you're talking about soft cotton, all the stuff that we wouldn't in a normal year be able to breed for, or it would be too cost prohibitive. Because I'm sure there are, strains of cotton out there that are super soft. It's a market that's probably not a mainstream market, but we're able to bring that super soft cotton into the mainstream because we're not worried about it, about the yields and it dying. We can put it in a tough plant and just make the output better.
For some reason in my mind, I was thinking about taking like a pine tree and crossbreeding it with some cotton plants so the wood that you walk on feels like cotton. It's not feasible in my mind. Like it's possible, but it is what came up with my mind. I'm all over the board today, Nick. I apologize.
No, you're good. I did want to get to your other question too about how 37% of people think genetically modified organisms are safe. And there's two things.
That hurts my brain.
Well, as soon as genetically modified organisms came out, there was a media blitz about how unsafe it was and how like mad science it was. I forget who started it, but someone had this first thing, and it was like made it seem like it was just like a bunch of people taking genes from whatever, putting them into anything, and then just randomly. And then also, humans don't like anything new. Never have, never will. And that's just the way it is. We don't trust anything new. I mean, you can go back in time and you can read accounts of how people thought the car will never replace the horse, or airplanes will never replace trains. Like how stupid? How are you kidding me? You're gonna get in a flying contraption when you can take a much safer train? And how did that work out?
I'm just trying to imagine going back to the 70s and try to tell someone, yeah, this house phone that's connected to your wall, that's not going to exist in like a couple decades. Wait, what?
Or what about like debit cards? You're gonna tell me that all this all my money is on this card and I can use this instead of carrying around cash? I mean, that was probably the same thing. People just don't like change. Anything new is scary and foreign, and that's the way we were not raised, but back to kind of instincts. New things scare us. New experiences are scary. Strange new animals are scary.
So, to me, the 37% of the general public believes that GMO is safe. Then 88 point something percent of scientists that are involved with genetic modifications all say it's safe. I'm going to say that the 37% that do think it's safe has probably done their research. The other 70 odd percent or 60 odd percent has not. It's, I think, lack of education, because I don't know about you, Nick, but I don't remember really learning about GMOs in school at all.
I definitely learned about the rice in school. That's kind of where I pulled that data out of my ass, but I definitely learned about the vitamin A in rice when I was in high school.
Interesting. I'll be honest, I don't remember any GMOs in middle school or high school at all, to be honest with you.
I don't even think they called them GMOs though. I don't know. I don't remember what we called them, but I do remember learning about it. But again, I don't think they had a name for them. I think it was just like, is in history we were talking about something and I remember reading about it in the textbook. It's just like a little blurb, but it was in there.
Weird how the world has changed. But again, another good reason why we kind of touch on it here and there, but another good reason why GMOs are important is less pesticides, insecticides, herbicides. It means not only costs will go down for growing the food, but also the invasive species or bad species go down. And in case you're wondering, the species that we do want, like bees, butterflies, ladybugs, have been shown not to be negatively affected by GMOs. So if we can remove their competition through GMOs, in fact, we're probably helping the insect species we want with GMOs, which I thought was really interesting.
Yeah, it's funny that this is a solution to pesticides. Like this is an actual solution to putting less pesticides on the ground, and people are much more reluctant to do this in favor of conventionally grown crops.
Damned if you do, damned if you don't. I since starting this podcast, Nick, I swear the farmers can never win.
Yeah, you're not wrong. Do you see? This is. I was like, man, it's so frustrating, like trying to explain agriculture to people because there's so many misconceptions. Like to me, there's a lot of there. We'll get to the dangers of GMOs sometime here, but this is the one I, that I just don't understand. Of the same people who are very anti pesticides, anti conventional crops, this is the solution, and it's like this is worse somehow.
We have a nail. How are we gonna get the nail in? With a hammer. You're gonna use that blundering weapon of death? No, we're gonna use the hammer for the nail. Oh, God, never mind. But since you brought up problems, there is one major. Well, I have a couple concerns with GMOs. The one that's more prevalent to me, and it seems to be to other people, is monocultures. I don't know if you want to jump into problems right now or if you have more to add.
Yeah, let's go with problems. I don't have monocultures, so you're gonna have to do that one.
Uh, Monocultures have always scared me because monocultures is a weakness for not just the plant but all of humanity. We've had multiple different types of organisms go completely extinct because they were just one type of DNA, one monoculture just completely gone. And before I say my opinion of this, I want to read a Belgian scientist. He's a molecular biologist who rejects the idea about, GMOs and monocultures being like GMOs negatively affecting monocultures. He goes, there were monocultures in agriculture a long time before GMOs appeared. Monocultures are always negative. Agrobiodiversity, cultivating a lot of different crops and varieties, is obviously important. If you see how plant diseases evolve, how plants defend themselves to diseases, the variants, the more resilient to pathogens, it's the economy that drives monocultures. It's overpopulation that drives monocultures. I agree and disagree. I agree that monocultures does appear in nature. I disagree how it's what I got from his statement was how common monocultures are. Monocultures to me are a very weak chain in the link of a chain of that you just don't want. Because for just a kind of quick synopsis of this, if you have bananas, for example, bananas are a perfect example. I think majority of all bananas in the world have the same DNA. So if a new fungi, new bacteria, new disease comes along that affects one of them, it affects all of them. And we could have another second extinction of bananas. That's the same thing with all GMOs. We might make it if we make all our wheat resilient to one thing, they're so similar that when something else comes along, it kind of wipes them out. Now, this is kind of a broad stroke statement, but it does merit some truth. Monoculture has always scared me too because to me, a monoculture negatively affects the ecosystem it's in. And when you throw in GMOs, we move away so much from the original, and Mother Nature is so good at modifying a plant to survive its environment that when we create a monoculture that's so foreign to its environment, it could completely wipe out an entire season. Imagine, Nick, an entire harvest of potatoes across the world completely gone because, say, hypothetically, we make all our potatoes resilient to X. Well, for DNA, if you modify something, there's always a reaction. It's always give and take. It can't be exactly perfect. There's always an equal and opposite reaction to whatever reaction you do. So if you make a potato resistant to black mold, well, now it might be a little bit more receptible or might taste better to a certain type of beetle. And then that goes through, and et cetera, et cetera. So monocultures have always scared me, and with GMOs, it seems monocultures are more prevalent. And I don't know if you agree with this statement. Like you said, Nick, you didn't really research monocultures, but I see GMOs and monocultures being very symbiotic relationship. The more GMOs we have, the more monocultures we have. And the more monocultures we have, the more open we are to a vulnerability of something wiping out an entire species of edible food. And I would like to hear your opinion upon it.
Yeah, so I think, yes, monocultures are, I'd say, a necessary evil. I mean, we got a lot of mouths to feed and a little ground to do it, and you can't have multiple crops in one field just because of the harvesting techniques for most of them. But I did want to talk about some other monocultures that I'd call strong monocultures. You talked a lot about monocultures that are weak, but throughout
Well, if I
time,
can I add on to that,
yeah,
if I can add to that before you talk about the strong ones, I do agree that monocultures do exist throughout time and they have happened, and they happen in nature. But now with humans traveling so much export, they're not isolated anymore. Each monoculture is each ecosystem is connected one way or the other to another ecosystem across the entire world. There are no more pockets anymore. Everything is connected. So that's, to me, another caveat for against monocultures, because a monoculture could naturally happen in the Amazon, but now that we're traveling so much, explorers go out, brings another species, kind of goes back to invasive species, but that's another negative attribute I see to monocultures. Sorry, Nick, didn't mean to interrupt you there.
yeah. So I might butcher this, but I highly recommend the book Eternal Frontier. It'll really help people understand how plants and animals move around and interact with their environment. But throughout time, plants have traveled from continent to continent, not just around continents, but they've been moved continent to continent. And they're what we would consider an invasive species today. They'll come in to an area and just completely take over. And I'm trying to think of a good example of one, but I can think of. Unfortunately, I loaned my book to Mike. I would go reference it if I had it, but and give you the exact, story. But a new plant will come into an area as an invasive species. This is way before humanity started spreading seeds and doing everything that we do, and completely take it over. And in 10,000 years or so, it'll just become part of the environment. And this is a very normal part.
Isn't a dandelion one of those creatures?
Oh, I'm sure it is. It's a very normal part of how nature moves around and how everything works out. It's so monocultures come and go, and I can think of, we have a lot right now in the United States. Monocultures, most commonly known as invasive species, like kudzu out here,
Honeysuckle by me.
in unmanaged lands. Himalayan blackberries completely taken over some wetland habitats, like completely choked everything else out, which is a monoculture. Now, given enough time, that'll go away. It'll become just another part of the ecosystem as other plants learn how to adapt and live alongside it. But as of right now, it's a monoculture. So it's not unheard of. Now, you also don't want to put all your eggs in one basket, which is what Mike's talking about. You have some genetics come through, but I don't think that's quite the case, because as genetic modification becomes more diverse, more common, some farmers will select a seed that, hey, this one has better yield. Or, yeah, but this one has a resistance to a blight that is infected, is stuck in my soil. It really helped me to get rid of it. It's not the same genetic material. It's two different crops still. So even if there's a lot of genetic modified crops, it doesn't necessarily mean that they're all the same genetic code. And as this keeps going in the future, I'm sure we'll be able to have, like a few different, maybe the same, crop, say like 5 different varieties of soybeans that all have a code for something, but different parent genetics to increase that diversity.
You made me think of something. It's kind of bringing back to FDA and monocultures. Does the FDA check genetically modified organisms yearly, 5 times a year, every 5 years? Because I imagine, like, plants naturally mutate. If you genetically modify a tomato plant, 5 years later, it's probably not the same tomato plant. I could be mistaken. If you let it, naturally breed, you're not really controlling it. Does the FDA have regulations on that? Like, do they check every year or so on the seed and DNA of the sequence?
I'm sure. I think that would actually be the USDA, who would do that throughout time, or the EPA. The FDA is just responsible for like consumption safety, because EPA, like we talked about with pesticides, it's the once it's been approved, it doesn't mean the testing is stopped. It just means that it's reached a certain point, and they continue to monitor it. So I don't know why it would be any different for genetically modified crops.
Well, I'm just wondering if they're testing the DNA or if they're not, or they're just checking for. Because I'll be honest, I don't really know if the EPA tests like DNA. Like, if you check apples, are you just checking for the quality of, does it have this many chemicals in it or not? Chemicals and DNA are two different things. So I don't know. I didn't expect you to know the answer. I just thought it was interesting. I'm wondering just what the checking process of how many times it gets checked, how often it gets checked, or like because mutations happen, et cetera, et cetera. What you start off with might not be what you end up with.
Yeah, I do know that they do check for its, if it's going to before it gets released to the public, of how it will breed and interact with other plants around it. And I don't know exactly how they control that, whether they make them sterile, one-time use only, or what the deal is there.
Well, speaking of sterile and one use only, that's another problem I see with genetically modified organisms. It's great that we can make it a one time product, but I also see it bad for the small time farmer. Imagine you have a field that's being overrun with some type of pest, and you buy some seed that helps prevent it. But the seed doesn't produce any offspring. It bores fruit, but the fruit is sterile. Well, now you can't save seeds. You can't reuse the seeds. You now have to buy seeds every single year from this one place. It seems very turnkey for a company to produce genetically modified food that can only reproduce once. And that is another major concern to me.
But that's how it normally goes. You have to buy your seed every year for the most part. Because, okay, look at it this way, kind of like pesticides. GMO crops are a pesticide, so you have to, the company's got to recoup that loss sometimes. Like it costs, and I don't know how much it costs to license a GMO crop, but for pesticides, anywhere from like $2 to $7 billion, which is a lot of money. Now, I know that the companies have to recoup that cost somehow, and if they made it so that you could just sell the seeds once and keep farming it, the initial cost of those seeds would be ridiculous. And it's in a lot of contracts. You have to buy your seed every year because it's a ton of seed too. You have to buy, and like it's not like something you can store for the most part. So if you're gonna buy a seed from this company that has increased yields or whatever, you got to play by their rules. It's kind of the way I see it. It's you have to sign a contract, that you're not going to do that. That's because it's their product. Now that's different. Like we talked about with the in Africa, where they're doing the public use stuff, they can save that seed and not use it over again.
I agree with your statements, but it still seems very dirty to me if you can't save any of your seeds. Like, I understand not being able to save enough seeds so you can replant your fields, but if I grow, I don't know, green peppers, and I want to save a few seeds for my own garden, just next to my house, but I'm not even able to do that, that seems very off putting to me. It seems very, I don't know why, it just seems wrong to me. I know that most farmers buy their seeds so they can replant their fields for, mass production, but to not even have the option to save seeds doesn't seem right to me.
Well, if you're worried about GMO crops interbreeding and getting away, and you just start giving away seeds to everyone, that's exactly how you get that. I mean, I don't know if that's why they do it or not. I'm just saying, like, that's a concern people have. So if that's a concern, why would they just start giving them away to every single person?
That is a very fair point. I did not think about population control. I did not think about that at all.
And again, I don't know if that's why they do it or not. I'm just thinking out loud.
Well, just thinking out loud, and we're still on problems. I want to bring up fads. I am also very concerned about fads. So overall, I want to put this. I think GMOs are a good thing. Humans using GMOs for dumb reasons, kind of concerning. So, like Nick mentioned earlier in the podcast, GMOs not just for food bearing plants, but also flowers. It's a very fashionable thing to have genetically modified flowers that are, colors that don't exist in nature, et cetera, et cetera. Well, my mind went to, well, what happens if you eat genetically modified food to taste different than what it looks like? A strawberry that tastes like a cucumber that tastes like watermelon. When do we draw the line? And will the market of fads like the avocado in California, which we always talk about, kind of dictate it? It's kind of concerning to me because if we follow fads, we might go down the track so far away from where we started that it's unrecognizable what we have. Imagine blueberries completely ruined because some fad. So what we taste now for blueberries will never exist. I don't like that idea in my head, but I can see it being a real possibility. What's your opinion on this, Nick?
Well, I think you'll have some growers grow a fad crop, but I don't think you'll ever completely. There'll always be a market for maybe traditional, and maybe that's the next, market of these are non-genetically modified crops. These are traditional crops of this blueberry tastes like blueberry and these
Which
snozberries
tastes
taste
like
like
snozberries.
snozberries. But yeah, I mean, as we use this technology more and more, it's going to become easier to do certain things. Now the question is, how big is that market going to be? Is it going to be worth it to, say like blueberries where you have to have bushes that take I don't know how long, but I think they take like a year or two before they start producing like reasonable quantities of fruit to grow into that fad. Or I think some growers would rather just keep their bushes that they already have, trim them, and not grow blueberries that taste like strawberries. But yeah, I could see it, and I definitely think that's going to be a thing. But also at the same time, remember, not too long. I mean, shoot, I say not too long ago, but I think it was like 16, 12 years ago when Heinz had that purple ketchup, and it was ketchup that was dyed purple, but it still tasted like ketchup. And they had the green ketchup too, and they thought it was like the coolest thing ever, and everyone's like, "That's disgusting."
Yeah,
I feel like you might have some of that.
that's true. I definitely imagine there'll be more misses than hits, but it only takes one hit to completely ruin something. Like rose. If you make a rose a certain red that's more vibrant than other roses, we might lose that DNA structure forever. I don't know. It not seed saving, but DNA sequence saving is kind of important to me. I don't know why. Just so we don't lose certain traits and stuff like that. Like a DNA database is, I feel like a necessity, especially if we're gonna be messing with food.
Yeah, and kind of like we said with organics, if you want crops grown without any of this stuff, you're gonna have to grow it yourself. You want completely pesticide-free crops, you're not getting an organic. You want completely GMO-free crops. I got some salt for you, but there's still a lot of GMO-free crops, but I don't think it'll be that way in the future. I think it'll be more common than not. And there's labeling requirements by 2022. Every crop that has genetically modified material in it, has to be labeled. And but man, it, there's a lot of people who are very afraid of all this, and no one's stopping anyone from just growing their own food. I like. I
But
mean, there's no
Nick,
one
that
out
requires
there.
work.
Well, and that's the whole problem, isn't it? Maybe that's what this whole thing has been about. We did pesticides, organics, GMOs. All it really is people want food grown a certain way, but they don't want to do it. This wasn't even about agriculture at all.
Just humans being lazy. But I've been kind of rambling about my problems. Do you have any problems that you see GMOs having, or just the market of GMOs?
So the one that we kind of touched on already, like you touched on, is what happens when a genetically modified organism breeds with a non-genetically modified organism. Of how does that alter the genetic code of that species? Are we going to have genetics going? You know, organisms evolve at a certain rate every year, every couple, however many years they'll split off from the genetic tree. Once we pass 2020, is it just going to be like a huge family tree, like just going every which way? We're going to have a new code of taxonomy, a new system to label the different families and relationships that organisms have to each other? Or will we have a pure taxonomy and a modified taxonomy?
I don't know why it's so funny to me. I keep thinking of a carnivorous plant having their DNA spliced in with a wheat, so the wheat is now like eating things in the field, and it's like a horror movie. You run through like a field of corn or wheat, and the plants just all attack you. I don't know why that can't popped in my head, but it just did.
Yeah, so that wasn't actually one of my fears, but it sounds like you got something there. And I don't necessarily know if that's genetically modified food's fault. That might be a personal thing. And then my other problem that I had concern was unknown allergies, like we talked about with the tomato that got the genes from the fish, or not the strawberry that got the genes from the fish. That you could, if you had a fish allergy, it could spread to that. Not would, just it could. That's an unknown concern. We're gonna have to do more labeling on food somehow of for allergies. Because man, if I was allergic to fish, I'm not gonna check the back of a thing of strawberries before I eat them. It's like there's gonna have if that is the case that it and the FDA is finding that it hits that allergy and causes it to flare up. There's gonna have to be some kind of awareness campaign or something, or some the word's gonna have to get out somehow, because my lazy ass is not checking the back of everything. But maybe if I had like a food allergy like that, I would. I don't know. I just can't imagine I'd be looking for that, in a strawberry.
Yeah, that still blows my brain that you have to be cautious of a fish allergy when eating strawberries. That sounds so foreign coming out of my mouth.
Yeah, it sounds like a joke.
Oh, it absolutely sounds like a joke. And if I can piggyback on one of your ideas with allergies, I am curious because, Nick, we live in a country where we could have food from all over the world. All of them could be potentially genetically modified. I am curious on how they would interact with each other. Like, say you're cooking a recipe that calls a lot of ingredients, a lot of foreign ingredients that normally wouldn't interact with each other. There's no way they can always be tested in every combination. And I imagine for the most part it wouldn't have effect on people, but I imagine there's got to be some effect on some people.
Like, so you're saying like you have, your maybe you have a code for wasabi that only interacts with taco seasoning and causes people to have heart palpitations or something.
Yeah, like
But
you
no one checks how often you combine wasabi and whatever else I said. What did I say?
tacos.
Oh, taco seasoning. Yeah, that's an uncommon combination, I imagine.
Yeah, or like you get guavos from a Caribbean country that are genetically modified, and you mix them with pineapples that are genetically modified in Hawaii, and you mix them with genetically modified blueberries from Canada. They probably all have their different regulations. You mix them together, they have different traits. You throw them into a blender, or even if we move away from fruit and we start doing meats or other vegetables that you cook together, and now there's heat involved, which make it easier to do chemical changes, you throw them all in like a skillet or a grill, I imagine that's got to change some of the molecular structures, if not the combinations of them. Like the only difference between what was it? Like like salt. Salt is we keep bringing back salt. Salt, you can eat salt, you'll be fine, as long as you don't eat 12 pounds of it, because then you might die. But pressurized salt will burn you and kill you. Just a little bit different combination, a little bit different feature, a little bit different environment, and now it's deadly. I can imagine with genetically modified, with multiple genetically modified combined, that might be a problem. Again, I think GMOs are a good thing. I don't really think that will happen, but I can see it if every country's doing it, every country having their own regulations, and some dumb fool like myself tries to combine foods and drinks together to see what it tastes like.
Well, I don't think I think every country would be different. That'd be a matter of national defense if all our food was the same source, you know? Because if all of our food was the same, all it would take, if China, so there's some hypothetical enemy of the United States, but we'll use China, all of us are using the same code, the same genetic material for wheat. All they have to do is change their genetic material for wheat and use any of their labs, which they may or may not have all over the place, and somehow figure out something that kills that wheat but doesn't kill their own wheat or any kind of wheat they want to make, and then they can pretty much ruin every other country. They do that same thing for all of those. So your diversity is going to be important for just defense purposes, much less just environmental purposes. So I think we're going to have something like that. I can't imagine a world where we have complete the same genetic material. We grow redwoods, which are redwoods. They're clones like of each other. That's how they kind of reproduce. So they're different clones. They're the same, like they're all the same genetic material, but we still grow multiple different clones to spread the risk around. So even though we're growing a lot of the trees are the same genetic material, we're not growing all the same genetic material.
I want to clarify. I don't want all the same genetic material. I want the same standards. So a certain amount of toxins, certain amount of just like the same kind of ballpark regulations. Like if you grow wheat in Nigeria and you grow wheat in Mexico, they all have kind of like the same standards. Like, this much DNA change allowed, or no acidic DNA splicing added in, just something generic like that. So that will eliminate the factor of like that in my mind. I want diverse plants. Again, I like going back to monocultures. I don't want monocultures. And having a worldwide monoculture sounds absolutely terrifying. But having an idea of regulation to make it easier to trade GMOs, to make it easier to intermingle between countries of food, I think wouldn't be the worst idea in the world.
Yeah, I'm just saying that I don't think you're going to have a monoculture just because of.
Again, I don't want monoculture, and I don't think we should go.
I know. I know you don't want it. I'm saying you don't need to be as worried about it as you are because. All right, think about this: the climate of Florida is much different from the climate of, anywhere in the Midwest. And if they're both going to grow corn in those places, you're growing corn with different characteristics to meet that immediate environment. You have very different soil types. Once we learn how to do this, we can focus in on the best corn for that environment. And since the environment differs from state to state, much less country to country, we're not going. I don't see a world where we have a global monoculture. It doesn't make sense as specialized as we can grow things to specific places.
Okay, you did not understand what I was saying. I want Florida and Indiana to have different corn, but I want them to have the same boundaries. So like this is not an example for genetically modified organisms. I'm just throwing it out there because one pops in my head. Lead levels, the amount of levels in each corn. The plants are completely different, but the amount of lead levels have to be below a certain limit. And the same, and like the same thing with genetics. So like I don't know, just like you can't use this bacteria because this bacteria might be danger to humanity, or if it spreads as an invasive species, it will wipe out entire populations. Just stuff like that. I want different cultures in different areas, even if it's the same crop. I just want guidelines so everyone across the board, across the world understands, like, hey, this is how we should do GMOs, so that way we can transfer them real easy without affecting other features.
Okay, so that's not going to happen because, well, just look at China with what is it with the babies, with the gene editing the kids, the CRISPR babies. So if there's a few bad actors, they're not going to listen to whatever rules. I mean, you have like your whatever many thousands of committees that the U.S. is involved in throughout the world that help set standards. I think most countries are going to abide by somewhat similar standards. They're going to be a little bit different based on country to country, but most people generally set some kind of relative standard.
Yeah, I agree with that. I'm just saying if we want more easily trade, I think it'd be better to have like a worldwide standard. And also, there are always going to be bad apples, pun intended. Uh, but if we just in the United States have, same kind of genetically modifications, which I assume we do in the United States, but we kind of show, because, all right, let's say the North America, Canada, Mexico, and United States trade a lot with each other. If we all had the same kind of rules for genetically modifying organisms, I imagine it would be better in the long run just for allergies. So that way we know what has fish in it, what doesn't, et cetera, stuff like that. I just hope that happens. I don't know if it will happen. And if I was a betting man, I would say that I doubt that happens.
Well, I think there's a pretty good chance it happens. It only takes one country, right? So, say if that's something that we want to do, that we're worried about it, the United States imposes that any product coming in the country has to meet these regulations. It's going to be a tough sell to give up that part of their market, either from, the Mexican side, the Canadian side. That there's a lot of trade that happens there, and to just say we're not doing that, they'd have to probably follow along just to keep selling to us. So it only takes one large consumer, and there is no larger consumer than us, I would argue, the United States.
Yes, I maybe. I don't know.
Now, I think what you're worried about is people saying, "Oh, well, we can't do this. We don't know what goes on over there." But we have already something where third parties, like if we import a wood product, we need to ensure that the wood product that goes into whatever the wood product we're selling at the end of the day, like some kind of laminated wood product or veneer or whatever, that product meets the sustainable standards that are here that a third party sets. So we send like neutral third party people to go and overlook the production of whatever other wood product to verify that it's okay. And I'm sure the United States does that, or other companies in the United States do that for different products, of sending people to go and ensure that if the products they're importing are of whatever, whatever they're looking for, percent organic, or I have no idea what else it would be. Not stolen lumber, sustainably produced lumber, stuff like that.
Ooh, sorry, you kind of caught me off topic with the stolen part, but I imagine the laws of stealing genetic code for GMOs, that's got to be a really hard thing to protect against.
I mean, at what scale?
Like, Farmer
Like,
A.
I feel like it would be pretty easy to figure out, yes or no.
Well, I imagine if Farmer Tom has pretty good crop yield and you take one of his plants, you figure out what it is, and you modify it a small percentage and say it's now yours. Like, how small a percentage does it take to have a whole different species that you call your own for genetically modified organisms? Is it one line of code in the DNA? Is it like 10 lines? I don't know. I didn't think about that until you mentioned the lumber and the regulation.
Well, I'm assuming it's somewhat similar to pesticides, where there's like I can't remember now, but I think it's like a 30-year. It might be different. Let's take a guess here. Say you got a 15-year patent. After 15 years, it rolls out. So say you put some fish genes in some strawberries, and then someone came and stole that and put some alpaca genes in those strawberries. That you would need to do to prove that that person stole it is show the fish genes that are in that strawberry that they added the alpaca genes to, and you still have the patent for 15 years. I think that'd be a pretty easy case.
But what happens if you add the fish DNA and the alpaca DNA? So now it's like 25% different, or it's just.
Well, I think if you anything involving those fish genes is probably under your domain.
I don't think you can domain an entire fish gene.
No, but you can domain in a specific fish gene, I'm sure,
I don't feel like you could.
because otherwise there's no money in it. Because then, okay, because the people who produce it need to be protected, right? Because here's what happens: Company A spends
See,
billions of like a million, some $2 million on the low end, just through regulations, just through getting their product paid. Probably another 2 to 12 million to think of the idea, get into something working. Company B copies it, adds a gene, pays 2 million to get it done, and now they have a product they can sell at, and they don't have to pay for any of the R&D. So how does that promote people to do, like, why? How? And if that system was real, there would be no incentive to produce any genetically modified organisms.
see, to me, from what my limited knowledge of patents, I can see the entire sequence of DNA being patented, or like a chunk, but I can't see a specific trait from a thing found in nature being patented. That doesn't make sense to me. Like if I took uh, AT CG AT from an oak tree, I feel like that's free up for grabs because it's an oak tree, and I could add that to whatever I wanted. But if I had the entire sequence, then that'd be something different. I could be wrong, but I'm thinking it's the sequence, not the trait.
So whoever first identifies the gene gets the patent to the gene.
Are you we
Once
certain
granted a
about
gene
that?
patent, the holder of the patent dictates how the gene can be used in both commercial settings and non-commercial settings, including research, for 20 years from the date of patent.
So if I just happen to find an animal in the middle of the woods that's never been discovered before, I get control of its genes.
Yes. So, and
That
let's see.
doesn't.
It gets So in DNA, human DNA cannot be patented because it's a product of nature. Because court-sided, because nothing new is created, nor when discovering a gene, there's no intellectual property to protect, so patents cannot be granted. So that decision invalidated previous decisions. But DNA manipulated in a lab is eligible to be patented because DNA sequences altered by humans are not found in nature.
Okay, so it just sounds like reverse engineering. I steal Tom's farm, see, like, oh, he's using this fish DNA. I can't use that specific code, but instead of using just that code, I'll add some other things to it. And
Yeah, but those companies do that anyway, so it doesn't matter if it's patented or not.
yeah, I agree with that statement, but I think that's just only the United States, and I think I'm looking at it at a global, and you're looking at it a local.
Yeah, but you also got to look at there's probably 6 companies in the United States that are doing this just because the initial cost
Are
is
we
so
gonna
much.
tariff everyone who
They're not probably not going to
copies
fuck with each other's shit.
our genetically
'Cause
modified food?
as it will, but right now, well, that's not true. Pesticides have been around for a long time. Well, it's no, it's not. It's not that it can't be done in the backyard. It's the licensing cost is so much. I mean, do you have 2 to 7 million to pay the feds to get your product licensed? Even if you have a product, you'd have to sell it to one of these companies, and then it would be their product.
So not necessarily a problem, but an interesting conundrum is when we go to space, obviously it should be GMO food to help survive. Hey, we were talking about trees and plants. Bring it back to space. Uh, if when we go to space, obviously we're going to bring genetically modified food because it can survive the radiation, harsh conditions. So I imagine in the future you're going to have Martian grain versus Earth grain, and we're just going to have two separate, like you mentioned, like family trees just split off. Like, how do you categorize a family tree where their ancestors was on one planet, but now they're grown on multiple planets? That seems like a naming nightmare to me.
Well, I think you'll have, like you said, two completely different books, right? We have an Earth classification that increases and it's kind of broad, right? Like we don't have a separate classification for all the different families of corn. It's just considered corn. And so maybe for a while, depending on. So there's, even in the scientific community, there's division between scientists over should this organism be lumped into one category or should be split into two species. And so you'll probably have those arguments, and they pretty much end when there's so much differences between the two organisms that you can't call them the same species, whether it be they can't mate with each other because they're too different, or they just exhibit very different physical characteristics or something that is just so different. So for a while, they might be pretty similar because maybe there's a characteristic that allows, Martian wheat to, grow off of less sunlight, but it still produces about the same, still tastes about the same, still grows about the same rate. I think it'll be a while. I mean, sometimes this is like thousands of years before a family will change into its next thing. So I think we're getting a little bit ahead of ourselves, and maybe I'm wrong. Maybe I'm not up to date on exactly how fast we can change the genetic code and how fast it will create a new species, but I think it's going to be a while before we get to that point. But I think when we do get to that point, I think it'll just be like a little footnote, like a little asterisk that says, so wheat, whatever strain of wheat, that genetic lineage will stop, and then it'll expand, and you'll have one that goes up and one that goes down, and the one that goes down will have a little asterisk next to the scientific name that says grown on Mars or something like that.
You did inspire a new bucket list item for me. I want a ultimate GMO space burger. I want beef from Texas, wheat that was turned into patties grown on Mars, and tomatoes grown in space like an International Space Station. I now have a new bucket list item.
It always comes down to Texas, doesn't it?
Ugh. I gotta tease you somehow. If we talk about trees and plants so much, I gotta talk about space in Texas a little bit.
There's gonna be people who've been living on Mars for 2 generations wearing a big old fucking Texas belt buckle.
You're probably not wrong.
You got anything else on GMOs?
No, my friend. I think we kind of hit all the broad strokes. GMOs is a little less complicated than I thought, but still a complicated topic. And I imagine there's some stuff we missed. And where can people tell us some things they want to tell us about GMOs that we missed or might not know, or other avenues to research?
You can hit us up on Backyard Philosophy Podcast on Instagram.
Can you find us on Twitter?
You cannot find us on Twitter. And I don't have a good reason, but you cannot find us on Twitter.
And because, well, Twitter is a dumpster fire. But Nick, reading any books lately?
I am. I just started David and Goliath by Malcolm Gladwell, and it's about how the underdogs usually win. And it's because they look at their environment in a way that the big guys don't have to. For example, in the actual story of David and Goliath, David used his slingshot to kill Goliath, a giant warrior. Goliath was expecting David to come across the battlefield and, fight him in armed combat. Goliath was this huge guy. David's a little shepherd. But David been using his slingshot, to scare away predators. And he's like, well, he knew he could not take this guy in a fight, but he knew that he could hit him in a soft spot and knock him out. So he did just that. He didn't have to engage him in hand-to-hand combat, so why would he? He would die. So he did what he knew how to do, and he won. And it turns out underdogs win a lot just because they don't play by the rules everyone else is playing by.
That sounds very interesting. I'm going to have to add that to my list.
I'll give it to you next time I see you. What are you reading?
I'm reading Why We Sleep by Matthew Walker, which is kind of a study on how sleep affects us, different types of sleep, how long-term, short-term it is, different scientific discoveries we've had based on sleep. And it's really interesting for me because it comes from the Berkeley Center, and I've had lots of research and articles I've come across that come from Berkeley. So Berkeley to me is a high praise. So I'm very interested in reading that. Just about to start. Haven't even cracked it open yet. Well, as always, thank you all for listening.
Thanks for listening to the Backyard Philosophy Podcast. We rarely finish a podcast without missing a point we wanted to bring up, so let us know what we forgot. And if you have a topic you want us to talk about, let us know at Backyard Philosophy on Instagram and Backyard Philosophy Podcast on Facebook.